Open your book to page 304. This is lesson 11.1. This lesson is about prime factorization and greatest common factor. So first, let's talk about prime number. Prime number is a number that is greater than 1 and has only two factors, 1 and itself. Okay, factors are what you can divide by. So you can have two factors. An example of the prime numbers would be like 2, 3, 5, okay, and 7, 11. So each of these is greater than 1 and has two factors. Like this one has factor 1 and 2, this is 1 and 3, 5 and 1. Right? So again, prime number is a number that has two factors, 1 and itself. Next one is the composite number. Composite number is greater than 1 and have more than two factors. So example of that would be like 4. Right? This one has factors of 1, 2, and 4. Right? And another example would be 6, because this one is 1, 2, 3, 6. Right? So you can composite is when you have more than two factors. Okay, like all these would be 1 in itself. Now let's go to prime factorization. Let's go to page 305. Example 2. The prime factorization. So this is for the prime factorization means you want to figure out what a number is made of and using the prime numbers. So for example 2, A, you have 30, right? So you want to break it down into prime numbers to find out what prime numbers are made of. So think of prime number would be like your ingredients, okay? So you want to find out what this is made of. And the way to do that is just go and divide it, and again, see prime factorization means you want to divide by prime numbers. So you start with 2, so it'd be 15. So you keep doing the same number until you cannot do it anymore. Then you go to the next one. So the next one would be 3. Okay? And so therefore 30 is equal to 2 times 3 times 5. Okay? So that's what it's equal to. So again, this is called the prime factorization, means you break it down into prime numbers. Then you go to B for 36. So you divide by 2, you get 18. Divide by 2, you get 9. Divide by 3, you get 3. So 36 equal to 2 squared times 3 squared. Okay, again, 36 is made out of the 2 squared and 3 squared. There are 2 of these and 2 of these, right? Okay, let's go to example 3. Okay, example 3. You're looking for prime factorization of 97. So now you're going to try. So 2 does not work, 3 does not work, 5 does not work, 7 does not work, 11 does not work. By the time you get 11, notice 11 squared is already 101 already, so it's past that. So that's how you know when to stop. By squaring the number, that's where you stop. So again, when you get to 11, 11 squared would be 121, so it's past that already. So that's how you know you can stop. So none of this can divide, there's no number that this can divide, so therefore this is a prime. Okay, so 97 is a prime. Okay, now let's go to GCF, or the greatest common factor. So let's go to page 306, and let's do example 4. So you're looking for GCF. So it says find GCF of 24 and 60. Okay, the way you're going to do that is you just divide both at the same time. Okay. And so you're looking for a number that both these numbers can divide. So both these are even, so you can divide by 2. So it would be 12, and it would be 30. So you can divide by 2 again, so divide by 2. So you get 6 and 15. So can you divide by 2? No, right? So 2 is done. So now you go to the next number, the next prime number, so 3. So divide by 3, so it would be a 2, and this would be a 5. And that's it. Okay, so the GCF would be the numbers on the side over here. So GCF would be equal to 2 times 2 times 3. So GCF would equal to 12. Okay, let's go to example 5. Example 5, you have 6x cubed and 15x squared. So when you're looking for GCF, focus on the number. Okay, so you got 6 and 15. So first focus on the number before you worry about the variable. So this one, you cannot divide by 2, so you go to 3. So divide by 3, this would be 2 and 5, and that's it, right? So your GCF would be the number on the side, so you equal to 3. Now you have to worry about a variable. So variable would be the lowest one, because that's the one that can divide into both of these. So both of these can divide by x squared. Okay? So you take the lowest one, and so that's your GCF. So you can use the latter method for the number, and the variable you just look and you can figure it out. Okay, let's go to example 6. Okay, you're looking for GCF of 5x cubed y squared. Then you got 10x squared y cubed. And then you have 25xy to the 4. So again, let's focus on the number first. So you got 5, 10, and 25. So all this can divide by 5, so 1, 2, and 5. So that's it. So your GCF, again, would be the number on the side. So you go to 5. So that takes the number. Now, for the variable, you just go down the alphabet, right? Let's do the x. So you got x to the 3, x to the 2, x to the 1. So you take the lowest one, so x. Then you go to the y. You got y to the 2, y to the 3, y to the 4. So this is the lowest one. So it would be y to the 2. Okay. The reason you have to take the lowest one, because that's the only, that's the one you can divide by all these, right? Okay, now let's go to example 7. So you're going to start to do factoring. So page 307. Example 7, so you're going to do factoring. Factoring means you take out what they have in common. So when you're doing the factoring, okay, I'm going to give you a handout. So these are the steps. So first, you do the common factor. Step 2, you do the special factor. And special factor, you have to look at number of terms, right? You got 2 terms, 3 terms, or more than 3 terms. And then after that, you do the cube and do the master product. So we're going to cover more of this as we get to it. So right now, we're going to do the first step. So every time when you're doing the factoring, okay, every time you're doing the factoring, you go through the steps. So step 1, let's go and do the common factor. Common factor means what do they have in common? Okay? So what can you divide both by? So example 7, you got 6x to the 3 plus 15x squared. So the number, so you look over here. So 6 and 15, both are divisible by 3, right? So you can factor out the 3. So again, when you do factor means divide. Okay, factoring is same as divide. So you divide by 3, it becomes a 2, and this becomes a 5, right? So you can check 3 times 2 is 6, 3 times 5 is 15. So take care of the number, then you do the alphabet. You got x to the 3, x to the 2, so you can factor out the x squared. Okay? And so again, when you factor means you divide. But easy way to do is just go and check what you need to multiply. X squared times x, right? X squared times x will give you x cubed. And try to line things up, it help you to able to do this a little bit easier. And x squared times, well, you don't need any more variable, right? So x squared times 1 will give you x squared. And you can double check, right? You can use, so you can multiply 3x squared times 2x will give you 6x cubed. This times that will give you that, right? And so that's your answer. So this is called a common factor. Common factor means you can divide by the number and the variable. Okay, so now let's go to example 8. you have 5x3y squared minus 10x to the 2 y to the 3 plus 25xy to the 4. So when you're doing the factoring, okay, get the parentheses to line up. And so you do the number and you go down the alphabet and you do the grouping like parentheses. Okay. So 5, 10, and 25, you can factor the 5. Okay. And so this would be minus 2. And now that's 1, right? So 1 and this minus 2, this would be plus 5. So that takes care of the number. Now you go to the alphabet. So you start with x, so you get x to the 3, x to the 2x, right? So you can factor the x. So you're going to get x squared, but don't write 1x squared, so just going to make it into x squared. Right? You can check, right? X times x squared give you x cubed. This would be x, right? You can multiply, use your fingers, right? And this one you don't need anymore, right? So you already have an x, so you don't need it. So you're done with the x, now you do the y. So you got y to the 2, y to the 3, y to the 4, right? So you can factor the y squared. Okay, so this one, y squared, take everything out, so you got 1 left, right? And you don't write 1, okay? So y to the 3, when you take out the y to the 2, you get y left over. And this one you can have y squared. Again, you can check, right? So this times that give you that, this 2 give you this, and this 2 multiply, you get that. Okay. So you can factor means you're dividing, and you can check your answer by multiply. This times that give you that, this times that give you that, this times that give you that. Okay. Okay, let's go to example 9. Okay, example 9, you have a negative 3xy plus 6y squared minus 3y. So normally you don't want to begin with a negative. So if you have negative in the beginning, normally you want to go and factor it out. Okay, so you don't end up with, your factor will end up with a negative. So that's going to factor out a negative 3. So I'm going to put in parentheses. So negative 3, and then we have to do the y. Okay. So the number would be negative 3, the alphabet would be y, because you cannot do the x, because there's no x over here to factor. Okay. But that's going to do the number first. So when you factor the 3, so the number is gone. When you factor the 3, means you get negative 2, right? You can check, right? Negative 3 times negative 2 will give you 6, right? And this would be 1, so it would be plus 1, right? So that takes care of the number, right? So now go down the alphabet. There's no x, so don't do the x. So just leave the x alone, right? You cannot do anything with the x because there's no x for you to factor out. Again, what we're doing is called a common factor. So common factor means they have to have it in common. So they have to have something same. So x cannot factor because there's no x over here for you to factor. Okay, now, so we're done with the x now. Let's go to the y. So you got y squared y, right? So you can factor the y. And so this is gone. And so this would be a y, right? Y times y give you a y squared. And this y is gone. So that's it. Now it looks kind of messy, so you can write it a little bit better. So you can do that. Okay, and that's your answer. Okay, let's go to example 10. Example 10, you have a times x plus y plus b times x plus y. So again, when you're doing the factoring, right, notice they have in common, see? So think of this as like a one factor, right? So this is a parenthesis, so this is a group. So when you're doing the factoring, first you do the number. So you do the number, then you do the alphabet. Okay, so you do the alphabet, and you do the group. So right now, there's no number to factor, so you go to alphabet. There's no alphabet to factor, right? When I say alphabet, means the variable by itself. So you got a and a b, so you cannot, right? Again, you have to have a same to factor. So you go to the group. You have the group of x plus y. You have group of x plus y. So you can go and factor it out. So when you factor means you divide, means it's gone. So it's gone. So you take it out. So only thing left is a plus b. And so that's your answer. Again, if you don't like the things get stretched out so much, you can rewrite it, right? You can have x plus y, a plus b. You can rewrite it a little bit better. Yeah. So again, so what we're doing, this is called a common factor.